Hello my dear students, in this video on the chapter data structure part 2 we are going to discuss two very important linear data structures, stacks and queue. So let us start with the stack. A stack is a linear data structure implemented in LIFO manner, that is last in first out manner, where the insertions and deletions all take place from one end, that is called top. It is a linear structure in which the LIFO order is followed, and there are two kinds of operations that are performed on this data structure. Let us try to understand these two operations. One is push and other one is pop. Push operation is a process of inserting new element into the stack. So whenever you insert a new element, you are performing a push operation. In this case, you will increase the top by 1. An element is appended to the list every time the push operation is taking place. For example, if top is a variable which is indicating the position where to insert the element, so top is initially kept at -1 when your stack and list is empty. Suppose I insert the first element here 10. The top will point to this element location. Again a new element is pushed into the stack. I will put 20 in the index 1. The top will point to this. Similarly, if I insert the next element 30 here, that is push the third element here, then this is the element inserted and this is called top will point to this. So every time will you push the element into the stack, you have to increase the top by 1, and this is known as push operation. And push operation means you are appending the element to the list every time you are performing this operation. Now come to the pop operation. Pop operation is removing the elements from the stack. That is, in this case you will decrease the top one and you have to remove the current element to which it is pointing. Now top is currently pointing to this element, so pop means remove this element and the top will be reduced by 1. So this is how push and pop operations are implemented on this list, and this makes a stack data structure. So finally we can say that it is a structure which is using last in last out order. See, the element last inserted 30 is deleted first. Similarly, if I want to delete now, the 20 will be the first element to be removed, and then 10, and finally if I remove the element 10, my stack will become empty and top will again reach to -1, because I will reduce the top every time I remove the element. So finally I can say that stack is such a linear structure which follows LIFO manner of insertion and deletion from one end, that is the top end, and that is the end which is managed by the top. This figure is also showing that push operation is inserting the new data values into the stack, and pop is the operation of removing the elements from the stack from the one end, that is this top end. Now next is stack states. We have three states of stacks according to the above things. Number one is underflow. When there is no element in the stack, that is top is at -1, when you cannot perform any pop operation on the stack, then this situation is known as underflow. Underflow is means that the stack is empty. Okay, this situation is checked whenever you are popping the element from the stack. Overflow is a situation where refers to the you are trying to push an item in a stack that is full. This situation occurs when the size of the stack is fixed and cannot grow further, as there is no memory left to accommodate new items. Peak refers to the inspecting the values of stack top without removing it. It is also sometimes known as inspection. So these are the three states of a stack which you have to be used. Now the operations that can be performed on a stack are mainly three operations. One is peak, that is only displaying the element at the stack top without removing it. Then second is push, that is inserting the new element into the stack from the top end. And pop is the process of removing, and that is the removing of the element operation, that is removing the element from the stack from the top end. Here is this example is showing how can be stack is implemented using a list. This suppose stack is the name of a list having elements 5, 7, 9. So 5 is first inserted, then on the top of it 9 is inserted, and the top of it 7 is inserted. Now we are pushing an element using the append function, append 7. The element will be appended, inserted into the list, pushed into the list. Then again stack dot append 11, it will push the element 11 into the list. Now if I print the stack list, this is the output. If I now pop the element from the stack, the 11 is going to be first removed, and then I print the stack, 11 is not there. Again I will use the pop function of the list, and then we will get 7 is the removed and 593 is the only elements remain. So this is how that data type list is used to implement the stack. Okay, and we perform the push and pop operations. Push is performed by inserting the elements into the stack using the append function, and remove is performed to remove an element from the element which is last inserted, to which the top is pointing. And the pop method of the list will help us to achieve the pop operation conveniently. So this is how the stack is implemented in Python using a list. Let us have a complete one program which is showing all the operations in this way. This is the program which is a function and menu driven, which is going to show you and implement the entire stack with this menu driven. Let us move to this program quickly in the Python IDLE. Now this is a simple menu driven program in which all the push, pop and peek operations of a stack are implemented through functions. Here list is there is a stack of numbers, is integer number is created using the list. Initially stack is empty, so stack is a list in which no element is there. Top is here kept none, which is equivalent to -1 where we have represented. None is inserted into the top because no top is currently not pointing to any index of the list. Now this is the loop in which I am going to implement the menu of the stack. These are the options which I am going to use. One for push, pop, display, peek, exit. Selecting the choice from the user, I will select the operation. If 1 is selected, I will perform the push, 2 is selected, I will perform the pop, and 3 is selected, I will display the stack, and 4th I will perform the peek operation, and if the 5 is pressed, I will stop this loop and come out, and if any other number is pressed, that will be an invalid choice. Now let us suppose the user is pressing the 1. So what will happen, this code of my program will be going to execute. Enter the number to be pushed, a number to be inserted, then I will call the function push and pass it to the array stack, list stack, and the element to be inserted. Let us move to the push function. This push function is going to insert the element I into the stack S, and then top will be here. I will increase the top by the length -1. Now why I have modified the top will be length -1 because here will be one element. Now -1 will make the top 0, yani instead of top getting none, now this top will be becoming a 0. So top will become 0 in this case, means top is changed. Now global top is used to refer this global version, global variable top. Otherwise if we use directly we do not write top, global top, this top will be local and it will not global version. Next is that if I press the option number 2, then it will going to implement the stack and it will going to perform the pop operation. Pop operation means remove the element from the stack. So suppose I have inserted 3-4 elements, pushed 3-4 elements into the stack. Now if I perform the pop operation, I already told you whenever the pop operation is performed, you have to check the overflow underflow situation. Overflow situation is to be checked whenever you are performing the insertion operation, and when the stack is implemented from such a data structure in which the size is fixed. But here the stack is implemented using a list and there is no limitation on the size. We can insert as many elements as we can in a list in Python, so there is no need of checking the overflow situation here in our example. But underflow still exists in this case. Underflow means if there is no element in this stack, you have to give a message that the stack is empty. Let us now move to the pop function and see how it works. I have passed the stack to it, that is the list. Now isEmpty is a function that is going to check whether there is not a single element into the stack or not. Now this isEmpty function, how this works, let us move to this function. See here, I am checking the length of the stack. If the length of the stack is 0, it means there is no element into the list. Stack length of the stack means this is 0, so this function will return true, else it will return going to return false. Now r is a boolean variable which is getting value true or false. If it is true, then my function pop will return underflow to the calling main function. Otherwise it will going to remove the element. Again I will access the global top version, so I have written global top. Now I am removing the element from the stack using the pop function of the list. Now pop without any index value will remove always the last element inserted, yeah, at the highest index, so it will remove that element and it will store give it element in the I. Now after removing, if the length of the stack is becoming 0, it means there was no element further left, then we can say that top is none. Again we will make the top reset, that the resetting the top to none. Otherwise we will simply decrease the length of the stack -1 as a top. It means we reduce the top by -1 and then finally return the extracted element. So this is how the pop function will going to work. Third is the display function. Display function is a very simple function which is going to display your stack from the first element to the till the top is reached from the index 0. So you are going to first check if the stack is empty, then it will print the stack is empty. Else if you will start elements from the top to the last, you will start from the top to index -1 and every time you are going to print the elements. If I is not equal to 0, then this is going to be printed every time. Otherwise you are going to print the elements, this first element, second element and third element and so on, and finally this will going to close. Fourth is the peek operation. Peek operation means you are just want to see the element without removing it. Now peek and pop are almost similar. Pop is going to remove the element, but peek is just showing you the element but do not going to remove it. Again peek will can return the underflow if there is no element to be peeked. For example, if the element to be picked is at the there is no element, then this isEmpty function will return the false and your stack will be returns true and it will print stack empty. Else you will just return the element where the top is pointing by using this statement return stack top, and the element will be returned by the function. So this is how the peek operation is performed in this case. Let us now run this program and show how these operations are performed. See, this is the menu which is appearing on your screen. Now there are 5 options. I am selecting an option. First one is the push. Let us now, I will push three elements first by selecting the option 1. First element to be insertion, suppose 5. Again I am inserting the new element, that is 10, and again I will insert the one element, that is 15. So I have inserted the three, pushed the three items into the stack. Let us display these three elements. See, when I use the option number 3, display 3 function will be called. It will going to display first 15 because 15 was the last inserted. Then this arrow is going to be displayed because every time I am going to display it, it will start from top to -1, and it will going to print these elements 10 and then 5. Okay, now I will remove an element from the stack, that is pop, and I selected the option 2. See, now this operation is performed and the element removed is 15. That is the last element which I have inserted. Now let us again see the stack. See, 15 element is removed from the stack. Let us first perform now fourth number operation, that is peak. This peak will going to display the element at the top, that is the element at the top is 10, but this element is not removed. So how can you ensure that it is not removed? See the display that element 10 is still existing in your stack. So this is how all the four operations are performed. And finally exit. So I think I hope you have understood this program, and this will help you to understand the. Let us now come to the another topic of stacks, that is the type of stacks. Now till now the stacks were implemented using the list of integers. Now whatever we stored in a list stack items is known as node. This node can contain data and informations. Whenever you are inserting the single numbers in a stack, we are storing only the data integers. You can store some other data also in the stacks using the list of list. For example, if you want to store the informations of the book code, book name, and their price, etc. in a stack, you can store. For example, I can here create a list of a list, and in which I can store the informations about the book. That is, I can store the information about the book such as book number and code, and can create a list and implement stacks of books in this way. Okay, let me show you this program and then we will proceed. See, this is the again menu driven program in which I am going to store the list of books as a stack into the stack. Push operation, when I perform the push operation, I will going to enter the following informations. I will just not enter the number. Instead of that, I will just ask the book number and the name of the book. Now these two variables will together make my list item. Now I am going to push this list into another list stack as a element. That is, stack will be my outer list and item list will be one of its element into the list. So I will going to push this element into the stack same way as I were pushing the number. So I will push it using the append function, and then I will modify the top pointing to the current element where I have pushed. So this is how my push function will work. Then after that, pop, display, peek and exit coding will exactly work will the same way as I have discussed. See, the pop function will going to check whether the ice value is underflow or not. If it is underflow, then it will going to print, otherwise it will going to print the element removed. Let us see the pop function. Pop function is doing first checking whether the stack is empty or not true. If it is true, then it is returning the underflow string, otherwise it going to pop the element, going to return the element popped into the I. Now modifying the top, if it length of the stack is becoming 0, then top will become none, otherwise top will be reduced by 1 every time when the pop operation is performed. So this is how the pop will be going to work. Display function is also going to work in the same way. It will going to first check whether the stack is empty or not, otherwise it going to display the from top to the 0 index, and it will going to print all the elements one by one. Okay, so it will going to print one list, the list of books, second list of books, and so on, the first inserted books, and so on. Peak will going to return only the element and not going to remove this. So let us now run this code and show you how can this perform, and how can a list of books also implemented as a stack in computers in Python programming. I have again executed the program. Now first I will select the choice number 1. I will enter the book number 1 and I will insert the name of the book, Learn Python Programming. Okay, so this see here I have inserted one book, Learn Python Programming. Again I am pushing the one more element, that is book number 2, Java is easy, name of the book. Okay, now I have inserted the two. Let us display these two books. See here, first book I have inserted, Java Learn Python Programming, and the second book I inserted, which is the top I book, now Java is easy. Let us now pop one book, no, let us insert one more book. Suppose I have inserted book number 3, and the book number is 3 is Let Us Learn C++. Okay, now again if I see the display, I will get the name of the 3 books and the 3 codes. Now if I pop the one book, see the last entered book, Let Us Learn C++ book is removed, and if I use the display, it will going to display the remaining 2 books. If I use the peek operation, it will just print the element at the top, but it will not going to remove it. For see here in this 3, if I display, this book is not removed. So push will remove the element also, and peek will just display the element. So this is how you can implement a list of books also using this. Okay, so this is the way you can perform the stack operations, and you can create and manage a stack in Python using the list. I hope you have understood this. In the next video we are going to discuss how and what are the applications of stack, and how can you use the stacks for various things in computer. Thank you.